The food web of the mangrove forest is again heavily reliant on the falling leaves and recycling of nutrients by the primary consumers and detrivores of the intertidal system, such as shrimp, crab, marine worms, and snails. The forest root system provides a substrate for the colonization by algae, barnacles, oysters, and mollusks. There are also fish within the mangrove forest, including groupers, snappers, and snook, that utilize the forest for nursery and feeding grounds. Wading birds like egrets and ospreys then prey upon the local fish and shellfish, using the forest for refuge and nursing as well. Other mammals utilizing the forest include black bears, raccoons, deer, and river otters. The red mangrove's ability to take hold of the land and tolerate salt water make it easy to be called the pioneer species in the mangrove's successional patterns. Red mangroves are found along the water's edge with full exposure to tidal variation and winds for propagal dispersal. Once red mangrove trees proliferate, an increase of leaf litter will accumulate at the bottom near the muddy sand, which over time turns into valuable nutrient-rich soil. Black mangroves are then able to colonize this area with less flooding. They are also not as susceptible to salty conditions of the ocean, so they are farther up the shoreline where they use pneumatophores to supply oxygen to the underground roots that are often in anaerobic sediments. The leaves fall with time and once again change the soil composition around the trees, and succession continues. White mangroves are the least salt tolerant and do not have special root adaptations to help with fluctuating salinity conditions, so they live farther inland within the forest as well. Although mangroves are heavily affected by the abiotic factors of the intertidal region, one of the biotic filters that is increasingly recognized as important for recruitment and population dynamics are the role of seed predators. Land crabs and the boring beetle are great examples of some of the seed consumers that prey upon the red mangroves. However, these organisms can limit the establishment and the growth rate of multiple species of the mangrove populations along the shoreline. Dr. Dragamond, an ecologist at UC Berkeley, wanted to study the effects of crab predation on P. rhizophae and R. mangle-dominated forests along the Caribbean and Pacific coasts of Panama. She later concluded that in most cases, predation by the crabs limited the rhizophora population more than the other species, and that predation upon the seedlings had more of a negative impact on the tree survival than the high mortality of seedling populations.